Hi, I'm Sean, and if you're seeing this video, it's because somebody was wrong on the internet. And I want to talk about it. So, yesterday, at least as of time of this filming, Theo put out a video talking about some of the changes to NextJS and what makes them cool. And this was the slide. Essentially, he did a solid job of breaking down how NextJS and how React and the React compiler are sort of optimizing performance by getting synchronous stuff out as quickly as possible. Not only synchronous, but as we'll see in a second, synchronous and synchronously available concurrent, which are two different concepts, I suppose. Anyway, that's part of what I want to talk about, and I want to talk about it because some of the choices made by NextJS, I think, could be better for portability, which is to say, I don't expect NextJS to run, in a browser or on the phone anytime soon. But it would be nice if it was simple to port to Deno and Bun and the rest, and the more important part, not only porting to those other platforms, but being able to run the same test suite and expect the same behavior the same way, the same sequence of the same events on each platform. And I think that's the problem that people might not grasp immediately. Anyway, we'll get into that. First, I want to look at this code. The slightly larger version of this code is this. There's actually a little more going on in the slide, but it is wholly irrelevant. The important part is just this. So what's going on is we see this new promise created, and we have two setImmediates. Now, setImmediate is wholly exclusive to Node. It only exists in Node and in pre-Chrome versions of Edge and IE 10 and 11. That is how narrow support is for setImmediate. So we have this setImmediate, and this is, of course, node-specific. It's intentionally node-specific. Apologies for, rambling. I'm just going to put this out and not do a whole lot of cleanup. And you're stuck with that. So we have the setImmediate, and what it is doing is it's essentially putting this in a queue, right? You might use a setTimeout 0. Those do not do the same thing. You might think of the more modern queueMicrotask, and the reality is queueMicrotask is just barely more modern. We won't get into the timelines, but we're talking the difference between 2011 and 2012, I think. Oh, whatever. In terms of when they were suggested and introduced, it's been a very, very long time. And introduced, I don't mean to the browsers or engines. I mean like conceptually as a spec. I might be wrong on the dates. Feel free to tell me I'm wrong if you were there and remember. Doo-ba-doo-ba-doo. Anyway, you can imagine setImmediate putting something on a queue like setTimeout. queueMicrotask would also put something on a queue like setTimeout. None of the three do it in the same way, and that is very important and is something that we will look at. Anyway, this first function goes on a queue. This second function goes on the same queue. And at that point, this second function calls abort on this signal, which ostensibly would be used to cancel any deferred promises that are going on under the hood in this JSX render, right? So you could imagine a whole bunch of suspense elements just waiting for components to come back, and each one of those components has a use effect, or now in React 19, a use, where it has some pending data fetch or whatever going on. You could also be using, any of the other methods to fetch asynchronous data. Right. So, like I was saying, you could imagine that this signal, by virtue of being aborted, is going to cause any further promises to fail. And that's just going to kick, whatever suspense boundaries into gear, or, anything else of the sort. However, they are wiring this up to get that spat out, whatever those boundaries are. All right, so that's essentially what's going on here, and it's cool. It's clever. I don't necessarily love how the error states are managed, but that doesn't matter. That's entirely irrelevant and kind of personal taste. What is important is this setImmediate distinction. So during the talk, Theo was talking about how setImmediate kind of comes in and the hijacks, gets in front of the microqueue, and injects itself in front of any tasks on the microqueue. And this is the big part of the contention that I have, for reasons that hopefully become abundantly clear, because it's not true. It's not even a little bit true. In fact, it's kind of the opposite. So here, very simple little file. Very, very simple little file. Not a whole lot going on. We've just got this setTimeout and two setImmediate calls, right? And we can imagine what's going to happen. We're going to see, setImmediate 2, setImmediate 3, and setTimeout run one after the other. And this stuff, just little helper functions. My goal is just to keep focus on the important code, the setTimeout, the setImmediate, and a couple of other concurrency methods we'll see in a bit. But there's nothing magic. So if we run this file, we see setImmediate 2, setImmediate 3, and setTimeout 1, right? Exactly like we suspected, the setImmediates happen before the timeout, and the timeout happens after the event loop and whatever needs to be handled. Okay, so on to the next file then. I'm just going to move my helpers into a little imported file. Again, nothing changed, no magic. We have queueMicrotask, right? So we have queueMicrotask and we have setImmediate. So we might imagine if Theo's statement holds, we might imagine the setImmediate happens before the queueMicrotask, right? So if it's really going to only grab the synchronous stuff, then the setImmediate, we would expect 2, 3, 5, 6, 1, 4, right? But I think what we're going to find is the very not that. Right? So what we actually see is 1, 4, 2, 3, 5, 6. So not only does setImmediate not jump in front of the microqueue, it actually jumps in at the end of the microqueue, which is a completely different behavior, right? And I might talk about it a little bit more, but that is sort of we'll get there. We'll get there. So microtask is first, setImmediate is second, and everything stacks like you would suspect if you expect setImmediate to come last. All right, so on to the next test. This next test, again, really not a whole lot going on here. And the purpose of this, we are introducing Promise.resolve. We're introducing Promise.resolve, and we kind of expect to get printouts of the time, the number of milliseconds since the script started running when we hit the log, right? So maybe we'll run this a couple of times. All right, so we can see Synchronous 0, 25, 50, 75, 100. Most of them are within a tenth of a millisecond. There is a 6 millisecond jump between Synchronous, the first Synchronous and the second. That's just a warm-up thing. That could be for any number of reasons. Whether it is the JIT compilation or provisioning memory or whatever, that is really just warm up. So it has nothing to do with the set timeout here. In fact, we can have these two synchronous functions fire side by side, and we still see that 6 millisecond delay, whereas everything after is, fractions of a millisecond. So not a concern. But let's look at what we have and what we got. So we have the first synchronous and then a set timeout. And then the second synchronous and setImmediate. Third, synchronous, and Promise.resolve. Fourth, synchronous, and queueMicrotask. And then the last, synchronous. So we might expect, based on the previous test, we might expect Promise.resolve and queueMicrotask to come before setImmediate, which comes before setTimeout. And that is what we get. Oh, I haven't rerun it. So let's rerun it. There we go. Okay. So we would expect Promise.resolve and queueMicrotask to come before setImmediate and setTimeout, even though setTimeout was defined first and setImmediate was defined second. So this Promise.resolve.then not only printed before the setImmediate, but it printed before the queueMicrotask. So both, and this is important to keep in mind, both a Promise.then and queueMicrotask will both insert callbacks into the microtask, into the microtask queue. So that is essentially what we're seeing happen, right? So to show that it is part of the same queue and there's nothing magical happening with the Promise.resolve that puts it ahead of the microtask, let's just switch the places of those two lines of code and rerun it, and then we will expect, if we're correct, to see the microtask and then the Promise.resolve still before the setImmediate, before setTimeout. Right, so we see queueMicrotask and Promise.resolve and setImmediate and setTimeout. Right, so everything lines up. All right, so hopefully we've now shown that Promise.resolve then will enqueue a callback into the microqueue, right? It is putting a task into the microqueue. So same deal with queueMicrotask, of course. And setImmediate appears to not be doing that, right? It appears to be doing something else, because if it was just pushing into the microtask queue, then it must be running before queueMicrotask and Promise.resolve.then, right? And if it's jumping in before the microtask queue, then it must happen before anything gets pushed into the microtask queue. But we can see setImmediate is called before anything in the microtasks, and it's called after all of the microtasks have finished. All right, so what's going on? Okay. So what we're looking at here, we have our Promise.resolve.then, and again, just shorthand helper functions, nothing more to worry about. Maybe Promise.resolve does work in that microtask queue, but maybe async functions don't, right? So let's check that out. So this is just an async function, and it returns this array that we're going to use in terms of, logging. And all async functions return promises, right? That's why you await them because they are async and they return promises. So it is returning a promise of this array. So we are going to attach a then and log the result. Right, so we have a then and a log and queueMicrotask. Right, so we just have these set up so that if async functions specifically do sort of fall out of the microqueue, then we're going to see that in action, right? We will see this then log first, and then the microqueue log second, and then Promise.resolve log third, and microtask fourth, and then the async function log fifth, right? If async functions really do kind of escape this this microqueue, then that would be what we see, right? Well, what we see is 1, 2, 3, 4, 5. Promise.resolve, queueMicrotask, async return, Promise.resolve, queueMicrotask. Right, that lines up with exactly the order the code is written. So this async function returns a promise, it's a then, and we apply it, and we log everything correctly. So what's going on if it's not even the async function that is allowing the setImmediate to jump in front? There are a couple of things to keep in mind. And maybe you already know them, maybe you don't. When we see new promise, like we saw in that first slide, or what was outside of Theo's thumbnail, we get this promise with this resolve, and we resolve with a value, right? This function runs immediately. So this function runs synchronously. And whatever you resolve with, if that value is available, if it is synchronously available, it is there, then this promise resolves synchronously. Right? So if the promise resolves synchronously, this then will be in the same microqueue as the tick where this promise is resolved. So you could imagine if we were just running a script, if this was the start of our script, this resolves in line in the script, right? So if you put a console log on above it, a console log below it, and a console log inside of it, they would run above, inside, below. This is evaluated in line. This then, if the resolution is synchronous, this then gets added to the same microtask queue. Right? If it's deferred, then it will be added to a different microtask queue. It will be added to the microtask queue whenever the fetch comes back, or whenever the image is loaded, whatever it is you're doing. Right? So it's important to note that when we're talking about synchronous promises, and not only synchronous promises, but synchronous async functions. So this function just returns this value, but because it's an async function, it returns a promise, right? So this then gets added to the same microqueue. And I apologize for anybody who is cringing at me saying microqueue instead of microtask-queue. The reality is I would go a little loopy if I had to say microtask-queue every time. Okay, so if we are clear that both synchronously resolved promises and synchronously resolved async functions both appear in the same queue, what's up with setImmediate? Well, there's one more layer of kind of misery here, and we'll look at it in a second. But setImmediate appends itself to the end of sort of an execution context. So you would imagine for each loop in your event loop, you have your regular call stack, right? That would be the call. Back after being so rudely interrupted by loss of electricity. Okay, so setImmediate appends itself to the back of a single execution context. So if you imagine the event loop as, you know, constantly spinning, and for each iteration, it will run whatever your call stack is. So you could imagine a callback, right? And it will run that single callback and all of the functions that that callback calls. And in JavaScript, we have the concept of a microtask-queue, right? So for queueMicrotask, for Promise.resolve, for a couple of other things, it's going to push things into that microtask queue, and those things are going to be, you know, run instead of being deferred to the next iteration of the loop. So setImmediate doesn't go in there. setImmediate appends itself to the end of both of those things, right? So not only does it wait for the regular callback to finish, it waits for the microqueue to finish. And then it runs. This is kind of an important distinction, because it leads to things that you would not expect to happen. Right, so we'll have a quick look. We've got a setImmediate here, and then a Promise.resolve with a whole bunch of thens, right? So maybe only the first then of a synchronously resolved promise ends up in this microtask queue. Maybe the rest of it gets deferred to, you know, the next tick or something. So we'll see what happens there. And then we have setImmediate. And inside of that setImmediate, it's got a synchronously resolved promise with a whole lot of ticks. Or a whole lot of thens. We don't know which tick things will, you know, arrive on. We'll see. Then we have another setImmediate to round it off, right? And again, no magic. Nothing that is, you know, hidden away is important to any of this. So let's see what we get. Okay. So we get resolve 2, setImmediate 1, resolve 3, setImmediate 4. So let's see what that is. We get resolve 2, setImmediate 1, resolve 3, setImmediate 4. So what this tells us is that Promise.resolve goes into the microqueue of this node script, right? The code that runs as soon as node is run. Like we said before, setImmediate gets appended after the microtask queue is exhausted. Right? So it would make sense to see resolve 2 and then setImmediate 1. Here is the other thing that we can infer from this, I suppose, is that if it is a synchronously resolved promise, then all of these functions that are chained are all synchronously resolved, and they're all pushed into the same microtask queue, right? They aren't deferred to the next tick, they're just added to the same queue if that value is ready. And the only way that would become untrue is if one of these thens, the handler for one of these thens, returned a deferred promise, right? It has a set timeout in it, or it is fetching something, or whatever. Right. So we have a setImmediate with a promise resolve 3 with a whole bunch of thens, and a setImmediate 4. So if setImmediate is supposed to jump in before the queue, that's not happening. And even funkier, a setImmediate that has a task queue in it, a microtask queue in it, that microtask queue will resolve before the next setImmediate. So what you actually get is a whole execution context, essentially. It's like, instead of going through the event loop, you go through the event loop, you do the in-place callback, then you do the microtask queue. setImmediate comes in below that and says, okay, now that those are done, run me and my microtask queue. And if there's any setImmediate called inside of the setImmediate, then it says run me and my microtask queue. Right, so this is the position that setImmediate comes in on. This is how it behaves. And all of that before the turn of the loop. Right, so this is the crux of the disagreement here. The crux of the thing to keep in mind. setImmediate is kind of weird in terms of how we think about it. Okay. So what are the takeaways here? First, the statement, the explanation of jumping to the front of the microqueue or jumping in front of the microqueue is misleading. It's not correct. And that's okay. People are wrong on the internet. I'm sure I have said something incorrectly other than just microtask-queue in this very video. Second big issue. setImmediate is both non-standard and deprecated, right? Really narrow support. It is Node, i.e. 10 and 11, and Edge pre-Chromium. I think that was everything before 18. Yeah. setImmediate can't be polyfilled reliably. So this is kind of a loaded statement. I'm sure that people who see this will say, but there are lots of polyfills for setImmediate. And there kind of are. There are polyfills for the behavior, but they... we'll talk about it in a second. We'll talk about it in a second. So here is my claim. Because of the above, NextJS will likely only be guaranteed to run the correct sequence in Node, or like Deno, other engines that jump through the hoops of creating a spec correct setImmediate. And that's actually an important distinction to make. Okay, so regarding, this first statement, setImmediate, it doesn't jump in front of microqueue tasks. It jumps in at the end, and it can create its own microqueue at the end of its own call stack. And sequential setImmediate calls do the same, right? So they jump in at the end before kind of yielding to the end of that iteration of the event loop. Okay, so regarding the statement of availability, this is straightforward, right? Only exists in Node and IE and Chakra Edge. So in terms of replicability, oh, that's not good. In terms of replicability, setImmediate, you can't have a consistent, like a well-behaved polyfill for setImmediate without having access to internals. So, like having access to the loop that is about to give control back to the host. Here we're talking about, V8 and UV, or libuv, or creating some particular kind of binding for that, or you have to hijack browser features that are spec'd in a way that you can predict when they're going to fire, because they needed to be that way for the browser specification for interop. But there's a problem with that too, right? I need to stop double clicking. So we know that message channel and post message, right? You're not going to get a message event in the middle of your code that's running. You're going to get that event firing after your code has finished running, right? After the call stack has exhausted. So we say, we can say, and this is what the polyfills do, we can say that if we can post a message, then we know we are at the point where the queue has exhausted, right? So some of the polyfills will just make a message channel and subscribe to its own messages, and then send itself a message when you are trying to setImmediate, right? Where the expectation is that that message will be fired and received by you at the end of the microtask queue. And that's going to work reliably in modern browsers. But Deno isn't a modern browser, and Bun isn't a modern browser, right? This is the problem that we have. And even if Deno and Bun do have, message channels and post message, they decide that they aren't going to implement setImmediate to the original spec, but they are going to implement message channel and post message APIs. The new problem is that message channel and post message would be really odd to be forced to work that way on a server, right? In a browser where you have one user and one tab on one page, kind of locking the message channel message events to the end of that iteration of the event loop, that makes perfect sense, right? But if you have 2,000 people active on your server at the same time, locking a message channel message event to the turning of the loop might not be a good idea, right? That might not be a wise idea, because you might be, trying to figure out how to make stuff run faster or smoother under the covers. You don't want to tie those servers responsible for serving thousands of people to the spec that is meant to deal with one person on one page of one browser. Okay, and so let's say we're going to ignore that, right? We're just going to put all setImmediates in the microqueue. Well, you see the problem with that. Any of the tests that determine on, are banking on microqueues happening before setImmediate are going to fail, right? If you put them in setTimeout 0, again, the order of operations will be wrong. You would expect all setImmediates to happen before any setTimeouts. So you can't do that either. This brings me to that last statement of portability. So to have consistent NextJS results, which are guaranteed to match Node.js, Deno and Bun and the like would all have to implement setImmediate at a deep level or implement the handlers for the hijacked BOM APIs, message channel, post message to operate on the server, serving thousands the same way it operates on one user's single browser tab to have the polyfill work consistently, right? This gets back to what I was saying. It also gets back to ultimately the problem that I have with setImmediate, the problem with how Theo sort of addressed it in the video, and to highlight that, here is a GitHub remark from the Deno repo in March of this year. So it says, adds a basic immediate class to mirror Node.js immediate and changes setImmediate and clearImmediate to return and accept, respectively, immediate objects. Note that for now, ref, unref, hasref are effectively stubs, as Deno core doesn't really natively support immediates. They're currently modeled as timers with a delay of 0. Eventually, we probably want to actually implement these properly. So note that even at this time, this may well mean, I don't know how much progress they've made in the last 8 months, but at the time of this posting, that any Next.js which had, a promise inside of it with a set timeout of 0, would then be fighting with setImmediate for which happens first. Right? This gets back to that, how do you polyfill this problem? And this is a real issue if Next.js wants to run in more places than just Node. Okay, so the takeaways from this. Do I think setImmediate is bad? No, not really. It served a decent purpose. It had good intention. There was an entire spec behind it and an entire expectation of having like easily yieldable long-running scripts. That was kind of, this was one piece of that bigger drive. I actually think Microsoft was like aiming at something good at that time. It also solved real problems. So setImmediate was one of those things where the hope was to allow us to concurrently handle values and still be able to, in that concurrency, do DOM manipulation or whatever else needed to be done before giving control back to the browser where it's going to do paint or layout. And that would sort of prevent some of the shifting and flicker and whatever else that you might see in those circumstances. And at the time, remember this was 2011 that it was, talked about, and 2012, I guess, when it was, shown off. At that time, we didn't have a whole lot of good substitutes, right? This is the world as everybody is trying to figure out how a request animation frame is going to work and how promises are going to be running as a standard and all of the rest. So everybody is fighting over this stuff. And eventually, the microtasks that the Promise standard supports end up becoming the microtasks that everybody adopts. And eventually, we get access directly to queueMicrotask. Right? So the NextJS solution itself would probably be better served as sort of an extension of microtasks and figuring out how to correctly schedule those microtasks, because setImmediate is going to pose issues if, like I said, if Next anticipates running on non-node platforms without running into the same concurrency nightmares that haunted my dreams in, the 2010s. Anyway, that's just a thought. I hope this wasn't too painful. Seriously, I look like a hobo in a tea kettle.